Hi, we're the battery-powered pickle jar heads, Team 4299 from Lexington, Massachusetts.
We've been a team for almost 6 years now. Amongst us, we have a lot of really different interests like origami, photography, music, to name a few. And what really brings us together is this common desire for inquiry and discovery. And we're really excited for this season of FTC so that we can explore the world of science and technology together.
As a team, we've been fortunate enough to visit many companies in the Boston area, including Lincoln Laboratories and Rethink Robotics. We've learned a lot from these visits. In particular, we've learned about agile development, which is a design process that many companies use. The idea behind agile is to break down a larger objective, in our case to build a robot, into smaller sprints. Each sprint we're able to build an iteration of the robot, and so far we've had 5 of these sprints. Having these sprints allows us to test many different ideas, including 3 drive systems, 5 different ways of lifting rings, and 9 different ring-grabbing mechanisms. Agile is a great way of how we've learned from others to create an awesome robot.
This is our 7th and current iteration of our robot. It's a culmination of all the past ideas we've had in our iterative process. It has a high-scoring autonomous program, and it can dispense rings really fast and teleop. In order to do this, we needed a really strong drive system. We chose the OmniDrive system because it's fast and maneuverable on the field. Despite the fact that some people have had issues with maneuvering the system on the platform, we found that with a heavy robot and a logical control system, we can mitigate these potential issues. We have 2 lifters on the robot. This is a dual lifter system, and they actually separate. This allows us to score 2 rings on 2 different pegs at the same time to speed up scoring. And notice they're attached to these individual grabbers, which allow us to do that. We wouldn't have been able to create this grabbing and lifting system if we didn't have access to tools such as the drill press and the lathe, and also a milling machine, which we're really fortunate to have access to this year. In order to have a high-scoring autonomous program, we use sensors such as the compass sensor and IR sensor to localize our position on the field, and then use these 2 EOPD sensors to align on the peg once we want to dispense ring and autonomous.
We really try and integrate algorithms for efficient moving, calibrating and using sensors, and for finding our position. One such algorithm is called Monte Carlo localization. It takes all of the sensors and it mixes them all together to give you a better idea of where the robot's position is.
The points in these diagrams are estimates of where the robot is positioned, as predicted by the Monte Carlo localization algorithm.
We designed our autonomous program to score reliably from multiple starting points, even in the face of defensive actions by opposing robots. For example, in this video, we use the ultrasound, a compass, and an accelerometer to recover from a collision with an opposing robot. We use the IR sensor to find the correct column. Then, once we're at that column, we use the EOPDs to align on the correct peg.
Our approach to community outreach has 3 main aspects. First of all, we like to reach out to professionals such as IDEO, Rethink Robotics, and Lincoln Laboratories. And reaching out to these design firms has also allowed us to gain their support, and this has contributed to our business plan. We also like to share the knowledge that we've gained over the years as an FTC team with other teams. For example, we taught a summer course as part of the Lexington Community Education Program, and it was the first student-taught course in advanced robotics. We gained a significant amount of money from this program, and this contributed to our business plan as well. We also like to reach out to other teams and encourage them, and this is part of our pickle philosophy, which is that a critical part of the FTC process is building your own team from scratch. And so we like to encourage other students to have the experience of forming their own team and going through the challenges of being an FTC team. We held a workshop where we gave first-time FTC teams tips on how to start their team. We also co-hosted a scrimmage with Lexington High School, and we'll be helping them with the Battle of Lexington qualifier in a couple of weeks. As a result of reaching out to professionals and sharing our knowledge and encouraging other teams, we found that there's a significant increase in the number of participants in the first program in our community.
10, 7, 3, pickle!